Okay, thank you, Jerry. Hello everyone. Today I would like to discuss about that hemoglobin replication efficiency of the contaminated with vertisoil and cambisol varieties. My advisor is Dr. Anabaye. My presentation will strongly stick to this presentation outline. As you all know, nowadays iron deficiency anemia becomes a concern of many scholars since it affects more than 2 billion people worldwide, and women and children are the most vulnerable groups due to some natural circumstances. In spite of research work that iron consumption of under 5 children in the northern part of Ethiopia is more than sufficient, anemia prevalence in Ethiopia is around 44%. This might indicate that not necessarily all consumed iron is utilized by a human being. Besides an economical burden, it impacts iron deficiency anemia impair the psychomotor development of infants. It also reduces the working capacity of adults. It can result in prenatal morbidity of pregnant women. This iron deficiency anemia is most common in a population whose diet is most composed of a plant-based food due to low iron bioavailability and high GAT agents. Teff is a self-pollinated worm-receiving grass, and its cultivation grows in wide environments ranging from waterlogged land to grass land, and its production represents about 22.6% of the total cereal production in Ethiopia. And back to 1950s, history told us that Ethiopia was the only country that produces Teff as a cereal crop. But nowadays there is a growing interest on the utilization of Teff due to its nutritional merits that are high iron content and gluten-freeness. And it was also an orthodox idea that Teff contains highest content of iron and considered as an excellent source for iron for the entire population. But nowadays, research investigated and tried to convince us this highest iron content in the Teff is due to soil contamination that resulted from crushing of the crop on the ground using a cattle hooves. No matter where the iron source is, whether it is extrinsic or intrinsic, the point is that what is the impact of this contaminant iron on the individual iron status? And with regard to this, there is two distinctive ideas. The first group believe that this contaminant iron is bioavailable and has a nutritional interest, while the other group believes that this contaminant iron is not bioavailable and has a poor nutritional interest. This is where it needs a due attention, because in both cases it might result in bad outcomes that harms the consumer health. For instance, if it is wrongly concluded that this iron is bioavailable, while the truth it is not bioavailable, it's also wrongly suggested that the iron dietary requirement is fulfilled or satisfied due to this contaminant iron consumption. This might also lead to the iron deficiency anemia, and the iron deficiency anemia also could be resulting on those health complications that I mentioned earlier. And on the other hand, if it is concluded that this iron is not bioavailable, while the truth it is bioavailable, it's also wrongly suggested to the fortification of iron to different cereal products. This also results in overconsumption of iron. And this also might result in oxidative stress and retarded growth in children, and also the increased susceptibility to infections. Therefore, we believe that it is imperative to assess and convince one of these distinctive ideas. And inspired by this thought, this research activity was initiated with a general objective of evaluating rat hemoglobin regeneration efficiency of Teff contaminated with vertisoil and cambisol soil varieties. We have our own reason to select these two soils. The first reason is that their widest abundance on the most cultivated land of Ethiopia, as suggested by FAO. And the second reason is that these two soil varieties are well characterized for their physicochemical property and shows the most promising bioavailable in the iron composition. And as a specific objective, estimating the bioavailability of iron from cambisol and vertisoil, predicting the hemoglobin regeneration efficiency of Teff's intrinsic iron, and interrelated bioavailability of contaminant iron to vertisoil and cambisol, and finally evaluating whether soil contamination blocks the intrinsic iron bioavailability. The Teff samples were collected from Debrahan and trashed in the mill in the laboratory, and the Teff flow were analyzed for approximate composition and total iron content as AOC 2000 official methods within a specific official methods. And the phase were formed The experimental diets were prepared based on the nutritional requirements of laboratory rats. And since vitamin A, B2, and B12 known to enhance or affect the hemoglobin level, and vitamin C enhances the absorption of iron, and some minerals like calcium and zinc is known to compete for absorption with iron, we try to equalize the mineral and vitamin content throughout the experimental diets. And also there is a 9-gram soybean oil addition to each experimental diet to equalize the total energy. And to show you the approximate composition of our experimental diet, here is the table. As you can see from the table, we try to provide equicaloric experimental diets to equalize the total energy of the experimental diets. And then 41 male Wistar rats aging from 3 weeks up to 4 weeks were collected from Addis Ababa University Biology Department and Ethiopian Public Health Institute's Traditional Medicine Department. And their weights were ranging from 27 up to 34 grams. And they were acclimatized under laboratory conditions by keeping them in individual cage and light and temperature controlled room, 12-hour light and 12-hour darkness. And then the depletion phase will take place, and the purpose of this depletion phase was to induce iron deficiency anemia to the experimental rats. And to do so, each rats were fed with iron deficient AIN93G for 3 up to 4 weeks until their hemoglobin level reached less than 6 grams per deciliter. And each rat having a hemoglobin level 6 grams per deciliter were divided, randomly divided into 4 groups for a repetition purpose, and each group contained 8 rats. And the first group were fed with a pellet containing a ferrosulfate and used as a control group, and the second group were fed is a pellet containing a vertisol camisol soil, and the third group were fed with a pellet containing vertisol, and the last group were fed with a pellet containing Teff. And for group 2, treatment group 1 and treatment group 2, we combine 0.55 gram of cambisol and 0.78 gram of vertisol soil in order to come up with 35 milligram extrinsic iron as it is suggested by different research. At the end of the depletion phase, that means after 14 days, the hemoglobin level were analyzed using HemoQ machine after the blood sample were collected using a more visible tailband. And throughout the entire experimental period, the rats were handled as per National Academy for the Care and Use of Laboratory Animals, and the ration and deionized water were ad libitum since the dietary restriction in rats were associated with different health complications. And also the ethical clearance were obtained from Addis Ababa University College of Natural Science Ethical Clearance Review Board. Iron consumption, hemoglobin iron pool, hemoglobin regeneration efficiency, and the relative biological values were calculated as it is shown in this slide. And while we calculate the iron hemoglobin pool, the assumption was that from the total weight of the rat, 6.7 is filled with blood, and among from this blood, hemoglobin contains 3.35 milligram per each gram of blood. The data were analyzed using a software Spaces version 20, and the descriptive statistics were used. The results were presented as a mean plus or minus standard deviation, and the statistical differences among means were tested by Turkey post-hoc test as 5% significance level. Sorry. And finally, we come up with this result. With regard to the approximate composition, we found the same result that has been repeatedly reported in different research. However, with regard to our iron content, we found 4 times and 25 times lower than the results reported by Ethiopian Food Composition Table and Ababa Ita respectively. This might be due to the possible soil contamination in previous researches, as both analyzed the test sample collected from ordinary marketplace. However, our iron results were in line with different cleaned and laboratory trash Teff flow as it is reported by different authors. This illustrated that we started at the initial with uncontaminated Teff flow, and the physicochemical property and the total iron content of these 2 soil varieties were illustrated in this table, and there was a significant difference in all the parameters except for pH. This allows us to see different impact of this different physicochemical properties, its impact on iron bioavailability. And there was no significant difference in initial hemoglobin, aging days, and initial weight, and also SLP status along the treatment groups. And this shows that our randomization were sufficient enough. There was also no significant difference in total food intake, iron intake, and weight gain, and also feed deficiency ratio along the treatment groups. This might be due to the similarity in initial weight, age, and the CRP status of the rat, since these three factors directly affected the total food intake, and the other three parameters, iron intake, weight gain, and feed deficiency ratio, is directly related to the food intake. There was no significant difference in initial hemoglobin gain and the final hemoglobin and hemoglobin iron pool and also hemoglobin regeneration efficiency along the treatment groups. However, there was a significant difference in all the parameters between the Teff and ferrous sulfate groups. There was also a significant difference in hemoglobin gain between the Teff and ferrous sulfate group and the vertisol and the ferrous sulfate groups. Regardless of the physicochemical differences in these two soils, there was no significant difference in all the parameters that are analyzed. The final hemoglobin of the Teff incurrence results were similar to the results from the Pingera and the laboratory Teklu, and also the final hemoglobin of ferrous sulfate groups were similar to previous studies reported by Hattamu and Weber et al. However, 58% of iron from ferrous sulfate group was converted to hemoglobin, and this shows the higher conversion rate than previous results reported by Weber and Hattamu. This might be due to the rats' age difference between the studies, since the younger rats were associated with the highest conversion rates. And figure 4.1 shows the relative biological value of the treatment groups. As you can see from the figure, Teff contributes about 80% relative biological value, and there was a 6.77% enhancement of relative biological value due to vertisol soil, and there was 7.44% of enhancement of relative biological value due to cambisol soil. The relative biological value of all treatment groups were lower than that result of fermented Teff reported by Urga. This might be due to two possible reasons. The first reason is that the combined effect of contamination and processing, more specifically fermentation, were reported to increase the iron bioavailability. And the second reason is there might be an extra additional contaminant iron from the processing equipment. However, our relative biological value were similar with a field trash Teff flow reported by Hattamu. This means additional 35 milligram extrinsic iron from vertisol and cambisol supplies from 6 up to 8% enhancement of relative biological value. In other words, 2.4 milligram of iron originated from vertisol and 2.6 milligram of iron originated from cambisol were bioavailable for utilization. This illustrated that some portion of extrinsic iron is from cambisol and vertisol are bioavailable, as it is suggested by previous research workers. As I mentioned earlier, there is two distinctive ideas on the contaminant iron bioavailabilities. Raphael, Abraham, and Smith reported in their in vitro study suggested that some portion of extrinsic iron ranging from 0.1 up to 4% is potentially bioavailable for utilization. In contrast to these authors, these three authors in their in vitro study suggested that the contaminant iron is not potentially bioavailable for human beings. However, they have their own weak spot in their study. The first limitation is that their model assumes ferritin formation is proportional to iron uptake, and the hepacity control iron uptake was not considered. In other words, iron uptake is only considered for a cell, not for a blood. The other limitation is that Teklu cells are a colon cell, and as compared to the duodenum cell, they have a lower transport rate of hydrophilic compounds. They are less leaky, and they are also less discriminant based on the molecular size, as it is suggested by user data. Every result from in vitro study has to be confirmed by in vivo study. Hattamu in his rat trial and Gibson et al. In their human trial suggested that some portion of extrinsic iron is bioavailable. In contrast, Minik et al. And Alcaso et al. Suggested that contamination of soil doesn't provide any bioavailable iron for human beings. but they have their own limitation in their study. The first one is they saw only the isolated effect of soil. However, the interaction effect is vital to see since soil might be bound to the mucosal layer after injection for a longer period. The other limitation is that they use outdated methods. They have very small sample size and unblocked confounding factor. Their statistical analysis were also inadequate enough. With this circumstance, it will be difficult to conclude that contamination of soil effectively blocks the intrinsic iron bioavailability. The relative biological value of Teff in current results is higher, which accounts about 79.5%, and was comparable and in some cases higher than some 45 fluors. However, further investigation that comparing the iron 45 fluor with Teff is needed. Table 4.6 shows the comparison of our current results with different iron 45 products. As you can see, we found 79.5%, and it is comparable and higher in some cases. As a study limitation, we only see the effect of two soil varieties on the iron bioavailability. However, these two soil varieties, as I told you earlier, they were well characterized for their physicochemical property, and they show a most bioaccessible iron, and they were also most abundant in the most cultivated land of Ethiopia. The other limitation is that hemoglobin regeneration assay of rats cannot be extrapolated for human beings. That means we could not predict the exact magnitude of the bioavailability of iron from this, since rats can secrete their own vitamin C and can also produce the fighters on the iron deficiency. However, with regard to the relative biological value, this model has been assumed as a golden standard. Having said this much about my results, let me draw some conclusions based on my results. Intrinsic iron from Teff has a good relative biological value and even better than some certain iron fortified food floors. And contamination of cambisol and vertisol has no effect on the hemoglobin regeneration efficiency. However, the enhancement of from 6 up to 8% of relative biological value were shown from this contamination, which is not negligible, particularly in the case of extreme soil contamination, which has been found in Teff, and also considering the healthy adult needs only 1 milligram iron to replenish their iron loss. Unlike a previous study, soil contamination does not interfere with the bioavailability of intrinsic iron, and promoting the production, accessibility and consumption of Teff could contribute to the efforts that are undertaken to control iron deficiency anemia. And further work that are covering more soil types and also assessing the potential hazards from heavy metal and others due to the soil contamination and iron desorption potential of various soil types. Human trial to test the Teff intrinsic iron bioavailability and also effect of mixed soil on iron bioavailability are strongly suggested. And finally, I would like to express my heartfelt thanks to my Almighty God for filling me with His wisdom, and Oromia Agricultural Research Institute for letting me study my master's, and my advisor, Dr. Kala Abaye, because for his intensive and unreserved support throughout the experimental period. And my gratitude also goes to Dr. Daud Gashu for providing me with iron deficient rat diets. At the middle of this experiment, I was about to start due to the shortage of these experimental diets, thanks to Dr. Daud. And those institutions and individuals which are mentioned or missed from this slide for taking part in this research activities directly or indirectly. Finally, I would like to thank you guys for your attention.